we're going to go over this applications to your normal model practice in finding percentages and proportions. So I want you to pay close attention to um, the notation and how all of that is written. So here we go. Okay, so here on this first one, the z-score was already given to you. And so it asked for less than that z-score. So look at how I wrote this probability notation. Probability that z is, here's less than that z-score. Okay, when I went and put it into my calculator, now what I have here in blue, you do not have to have written down. This is just so you know what I put into my calculator. So think about it this way. If you were going lower, this lower part area, then you're going from negative infinity up to that z-score. So you need to then go from negative 99 up to negative 0.66. And that gives you this decimal. Make sure you round to 4 decimal places correctly. So when you get to that last digit, that fourth digit to put down, you look at the one behind it to see if this one goes up or if it stays that value. And then turn it into a percent. All right, here we wanted to go greater than this particular z-score. So the z's are greater than negative 1.3. So greater than, you're going to go from that z-score up to positive 99. And there's your 90.32%. Now here we were going in between. And the important thing here is that we were going in between these two z-scores that are above the mean. If you have two z-scores above the mean, then that tells me they are positive. So look at how I wrote this. The z is in the middle because it is in between. And I put the lower z-score, positive 1.2 on the left, the higher one, positive 2.5 on the right. My inequalities point to the lower number because that's the smaller number because 1.2 is less than z, which is less than 2.5. So then when I put into my calculator, those are actually the bounds that I put in from the lower bound of 1.2 up to the upper bound of 2.5. So that's 0.1089, and that's 10.89%. Now, look at what happened on this next one. We were told that this is 0.6 and 0.2 below the mean. That means they are negative z-scores. So we have from negative 0.6 up to negative 0.2. So that z-score is in between those, and that's how I compute that probability, which if you round correctly is 0.1465 or 14.65%. And the last one, I didn't bold this, but I did italicize it, that this is below. So once again, these are negative values from negative 2 to negative 1.5. And that's 0.0441, which is 4.41%. Now, if you happened to do these first problems, or if you're ever getting the number, the percent that it gives you is a negative number. So for example, let me show you a common error that I saw with my students. So say they came here to do negative or norm CDF, and they went from, say, negative 2 up to negative 99. Okay, well, so this is out of order because negative 99 is lower than negative 2. So see, these are written backwards. So watch what happens whenever it calculates the area. It's giving me a negative number. You can't have a negative area. That's like a black hole. You can't have negative percentage or negative probability of something. So if you ever get a negative, you need to go relook at what you put into the calculator because you did something wrong. All right, let's move on then to now we have context. So here we go. So here we are talking about a student passing the exam. So the means were 42 and 80. A passing score was 50. So here's just kind of a picture so that you could draw it if you wanted to. So I got my z-score, x minus the mean over the standard deviation, and that was 1. So look at how I write my answer. The probability that z is greater than this z-score of 1. Okay? Now, what I have written right here in red, that's not required to write down. The calculator speak is not required. But this is a complete full answer that I want you to write down. So that equaled 0.1587, which is 15.87%. Next, our mean was 255 with a standard deviation of 2.5, and we wanted to see the proportion of bags that were underweight. So if they were underweight, then they weighed less than that location's amount. So I had to find the z-score there. So x minus the mean over the standard deviation was -2. So I norm CDF'd from -99 up to that -2. And here's how I wrote my answer. Probability that Z is less than -2, the underweight portion. So it rounded to 0.0228. See, look at this here. Round correctly. You are seniors in high school. You can round. 0.022, and before you write that fourth number down, look behind it to see if it stays the same or bumps up. Always 0.022, and before you put that down, see that it then rounds up. All right, so there's that one. Okay, now, whoa, I got a lot of stuff written here. Okay, so let's see. Oh, I go a little bit into depth about uh, a couple of different ways that you could write this. And one thing is to make sure that you are writing it the correct way. So let's take a look at this. So what percent of this age group has an IQ less than 100? So 110 was the mean and 25 was the standard deviation. Now, you know what? I had students that were wanting to do something with this 20 to 34. I mean, please, students, this class is about math applications and context. You need to read. You cannot just skim problems for the numbers. 20 to 34 is just a descriptor of the type of subjects that were used. Okay? That had nothing, that was not IQ values. All right. So we need to get into that habit of reading the problems and not skimming for the numbers. You have to understand what the problem is about. All right. So our mean was 110, standard deviation of 25, and there was the x value we wanted to know an IQ less than 100. So our IQ, our x value was 100. So that I do by x minus the mean over the standard deviation. X minus the mean over the standard deviation. So this is -0.4. So see, that is a location just a little bit, just almost a half a standard deviation below the mean. Now, let's take a look at these two ways that you write these. Now, in our calculator, we would need to do norm CDF from -99 up to that z-score of -0.4. And that gives us 0.3446. Now look at these two ways that I wrote this. The probability that z is less than or -0.4. If you want to leave it that way, that's fine. Leave it in z-scores, okay? Now, some people like to write the problem in context because this is what it asked. The probability that x is less than 100, where x is your IQ from that age group. So it's either way is fine. Just don't switch it up and say the probability that z is less than 100. No, the z-score is negative zero point 0.4. The context value is 100. Keep those correctly together and pick one and go with it. I think on most of the work for the rest of the unit, I do the z-score notation just to be consistent. All right, here we were wanting to know the IQ between 90 and 115. So 90 and 115 are 2x values. See here? We had 2x values, and we need to know what proportion of 20 to 34-year-olds have IQs in this section. So I had to get a z-score for both of them. Z equaled 90 minus the mean over the standard deviation, and 115 minus the mean over the standard deviation. So I got both of those z-scores from negative zero point 0.8 to positive 0.2, and that's 0.3674. Now, let's take a look at this notation. Again, I showed you both of these just so you could investigate which one you liked. So we wanted the probability that the z is in between. The z-score was in between this z-score, negative 0.8, and the upper z-score, 0.2. Or you could have said, if you wanted to use context values, the probability that x is in between 90 and 110. Okay, so whichever way you're going with it, fine, stick with it and go with it. All right. Now, I think I'm going to go ahead because I've talked a lot in this video and I like to keep them kind of short. So I'm going to stop there and I'm going to do another video that continues because we have a new situation happening here with it talking about how many students. So let me go ahead and stop this one and I'll continue the next video at problem number 9.